Hey guys, Mrs. Young here. Time to go over our Chapter 2 Energy Study Guide for our upcoming test. What is energy? Energy is the ability to cause change. What is the difference between kinetic energy and potential energy? Kinetic energy is the energy of an object in motion. Potential energy is the stored energy of an object. So for an object to have kinetic energy, it must be moving. If it is not moving, it does not have kinetic energy. Potential energy is the stored energy of an object. With potential energy, there is no movement. There is energy available, but it is not kinetic yet. What is mechanical energy? Mechanical energy is the combination of potential energy and kinetic energy of an object. So we can think of that as ME, which is mechanical energy, equals KE, which is kinetic energy, plus PE, which is potential energy. Anything that has moving parts has mechanical energy. So if it has a crank, if it's a wind-up toy, wind-up clock, anything with moving parts, machinery, that has mechanical energy. Based on the scientific use of the word work, why is lifting a box a form of work, but thinking of a homework plan not a form of work? Work happens when a force makes an object move. It takes an input of energy to create a force, so whether that be a push or a pull. Lifting a box causes the box to move. Thinking of a homework plan does not. Define potential energy and list 3 forms of potential energy. Potential energy is the stored energy of an object. The 3 that we talked about were gravitational potential energy, chemical potential energy, and elastic potential energy. We'll talk about those in a little bit more in depth a little bit later, but you got to think about that those are stored. Kinetic energy depends on the speed and the mass of an object. So that makes sense to me that speed would be associated with kinetic energy because speed is motion. So increase speed, increase kinetic energy. Decrease speed, decrease kinetic energy. So the other factor that is affected or that kinetic energy depends on is mass, the mass of an object. So mass is the amount of matter that an object has. So the larger the mass, the more kinetic energy. Less mass, less kinetic energy. So what is a way that we can remember that speed and mass go together for kinetic energy? Well, I think it's kind of easy to think of speed because if kinetic energy is movement, speed makes sense that that would go together. But mass, how are we going to remember that? So here's a little trick for you. I want you to think about that mass starts with an M and motion starts with an M. That mass and speed are dependent upon those 2 things help determine kinetic energy. Mass, motion is kinetic. Maybe that will help us remember that those 2 words go together for kinetic energy. How could you increase an object's gravitational potential energy? Well, I know that gravitational potential energy is between the object and Earth. So the higher I would raise that object off of Earth, the more gravitational potential energy I could generate. So an object's gravitational potential can be increased by moving it to a greater height. Name 2 ways an object stores elastic potential energy. Elastic potential energy is stored in objects that are compressed or stretched. It has to do with the shape. So compressed like a spring, making it really tight, and when you let it go, it can be converted to kinetic energy, or stretched like a rubber band, like a bow and arrow, like a slingshot. You pull it back, changing the shape of that object, elastic potential, and then let it go. It would be converted to kinetic. Energy is the ability to cause change or to do work. A moving truck has more kinetic energy than a parked truck. Well, that makes sense to me because moving is in motion and kinetic is movement. Parked car, there is no movement. So a moving car is definitely going to have more kinetic energy than a parked car. A large truck parked on a hill has more potential energy than a car parked next to it. Well, they're both in the same location. So the two things that affect gravitational potential energy are height and weight. And so a truck is going to have more mass, is going to have more weight than a car. So it is going to have more potential energy. Now, so gravitational potential energy depends on these two things, height and weight. The way that we're going to remember that these two go together is that it makes sense that height, because it is the distance off of Earth. And look at this. Look at the end of these words here, height and weight. Even though that they don't rhyme, they visually look the same. So we're going to put those two together and remember that height and weight go together for gravitational potential energy. You're going to need to know the kinetic speed and mass, and you're going to need to know the gravitational potential, height and weight, that those two factors go together. Which situation is an example of work? Well, for work to be done, there has to be movement. So if we look at these three scenarios, the only one where there is movement is a person hitting a baseball. What type of energy is the total amount of kinetic energy and potential energy in a system of objects? So this is the definition for mechanical energy. ME equals KE plus PE. Mechanical energy equals kinetic energy plus potential energy. Which example requires the use of radiant energy? So radiant energy is going to come from the sun in the wavelength. Starting a microwave or riding a bicycle? Starting a microwave, because we're actually going to use the electromagnetic wave called microwave in our microwave. So here are some energy transformations. On each term, on each line, write the term from the word bank that correctly completes each energy transformation. So anything that is plugged in is going to have electrical energy. Something that is hot is going to have thermal energy. So to make our toast, gotta plug it in, because if our toaster is not plugged in, it's not going to work. So we're going to chase that electrical energy to thermal energy. You can actually see that. If you look inside your toaster, you'll see the red wires that are heating up the bread. So watching television, once again, you got to have that plugged in or else it's not going to work. That's why these things don't work if we have a power outage or if they're not plugged in. So we take the electrical energy that comes to your house and convert it to radiant energy so that we can see it, and sound energy so that we can hear it. Using a curling iron to curl hair, once again, got to plug that in. And then with a curling iron or a flat iron, you know that is going to get very hot. So it's going to be converted to thermal energy. It's very hot to either curl or straighten your hair. Turning on a lamp, gotta have that thing plugged in. Electrical energy, it's going to change to radiant energy, which is light, and thermal energy, which is going to be a waste energy. We have, if you get close enough to a light bulb, don't touch it, but it's really warm. So it's a byproduct. It's a waste product from this energy transformation. It really doesn't add anything to the use of the light, but that light does give off thermal energy as waste. An energy transformation occurs when energy changes from one form to another. What happens to the potential energy when a ball is tossed into the air? Think back to when we have that basketball paper from a couple of days ago. Make sure that you are reviewing that. That's going to be important for you. So what happens to the potential energy when a ball is tossed in the air? Well, I know that gravitational potential energy is going to increase the higher I am off of Earth. So it's going to increase as the ball approaches its highest point. Going to reach a point where the kinetic energy is going to stop. This is going to be the highest point for gravitational, and then it will fall back to Earth. According to the law of conservation of energy, energy cannot be created or destroyed. It can be transferred from one region to another, and it can be transformed from one form to another, but can't be created or destroyed. When a ball is thrown into the air, its kinetic energy is lowest at the top. So once again, so as our gravitational potential energy increases, our kinetic energy decreases. So when the gravitational potential energy is at its highest, its kinetic energy is at its lowest, up here at the top. What type of energy transformation occurs during photosynthesis? Photosynthesis is going to be something that you might have a little bit of background knowledge on already, but that we'll touch on in chapter 8 in like April. So for photosynthesis, plants need photosynthesis to make their own food. They must have sunlight and water and carbon dioxide. So you get the sunlight from the sun. So that is going to be radiant energy, becomes chemical energy. The chemical energy is going to be that stored energy in the leaves or fruit of that plant. The amount of work done is a measure of force applied over distance. There has to be movement. The object will move in the direction of the force. So think about when I would push that chair in class and push it away from me. As long as I was applying that force, which was the push, the chair would move. As soon as I released the force, the chair stopped. When I pulled it towards me, then the object moved in the direction of the force, so it moved towards me. So either away when you push or towards you when you pull, but it's going to move in the direction of the force, and there has to be movement for work to be done. As a boy rides his bike down a hill, the sum of potential energy and kinetic energy stays the same, cannot be created or destroyed. So this goes back to that basketball scenario also, where when one increases, the other decreases, but they stay in balance. So this is going to end this first video, and we'll pick up the next page on the next video.